Picture this. You're on a perfectly normal flight. Everything's stable, the autopilot is on, the cabin crew is serving lunch, and up front in the cockpit, it's all routine. But hidden from everyone, a single sensor is telling a lie. It's a tiny, silent error that in just a few minutes is going to cause this modern jetliner to lose speed with no warnings, no alarms, until it's just seconds from the ground. This is the incredible story of Turkish Airlines Flight 1951. And that was the sound. The sudden, violent warning that just shattered the calm in the cockpit. It was the plane itself screaming at the pilots that it couldn't fly anymore. And for the crew of Turkish Airlines 1951, that warning came way, way too late. So that's the big question we're going to unpack here. How does this happen? I mean, this wasn't a case of a blown engine or some crazy storm. The answer is buried in this hidden chain of events. A place where really advanced automation and a very experienced crew just completely misunderstood each other until the final, tragic moments. When the end came, it was fast. The plane slammed, nose down, into a muddy field just a few kilometers shy of the runway there at Amsterdam's Schiphol Airport. The impact broke the fuselage into 3 pieces, but there was no fireball, no explosion, just this eerie, surreal silence. You see, for the investigators, this was the real head-scratcher, because right up until those last few seconds, everything on the flight seemed completely, totally normal. So to figure this out, we've got to rewind the clock and follow this flight right from its very routine start. So, let's set the scene. It's the morning of February 25th, 2009. A Boeing 737 is all ready to go at Istanbul's Ataturk Airport. All the checks are done, and everything is pointing to just another uneventful hop over to Europe. And let me tell you, the experience in that cockpit was immense. The captain, over 12,000 flight hours. The first officer had more than 4,000. And sitting in the jump seat was a training captain, an instructor, with over 15,000 hours. So you've got a modern jet, a routine flight, and a cockpit just packed with expertise. After a totally smooth takeoff, the plane climbed up to its cruising altitude of 35,000 feet. The seatbelt sign went off, the cabin crew got started with service, and in the cockpit, everything was textbook. Fuel flow was normal, engine parameters were stable. It was a good, calm flight. But, and there's always a but in these stories, isn't there? As the plane starts its descent toward Amsterdam, the story begins to change. Right at this moment, a faulty reading silently creeps into the aircraft's systems. It's just a single piece of bad data that nobody in the cockpit can see. So where did this lie come from? The left radio altimeter. Now, this device is absolutely critical. It doesn't measure altitude above sea level. It measures the plane's exact height right over the ground below it. And that information is vital for the final seconds of an automated landing. And the scale of the error here, I mean, it wasn't just off by a little bit. It was staggering. As the plane is coming down through 2,000 feet, the faulty altimeter is telling the plane's computers that it's at -8 feet. It basically told the automation that the plane was already underground. And this is the part you really have to understand. This wasn't some blaring alarm. There was no flashing red light, no loud system failure warning popping up. This error was completely invisible to the pilots, who, by the way, are pretty busy at this point, managing a high workload approach into a major airport. So now, this silent error is about to kick off a disastrous chain reaction. The plane's automated systems, trusting this bad data, are about to make a decision that is perfectly logical, but completely catastrophic. Okay, so here's what happened. The autothrottle, that's the system that controls engine power. It gets that -8 feet signal and thinks, oh, we're about to land. So it does exactly what it's programmed to do for a landing. It goes into what's called retard flare mode and pulls the engine power all the way back to idle. The pilots, who are expecting power reductions during descent anyway, don't immediately notice this fatal move. And this is where the trap really closes. At 2,000 feet, the engines go quiet. As the plane's speed starts dropping off, the autopilot tries to compensate by pitching the nose up to stay on the right descent path. Well, that is a deadly combination. You've got low thrust and a high nose angle. The plane is just quietly running out of energy, all while the crew is busy with their normal landing procedures. And to make things even worse, the plane was fully configured for landing. The gear was down, the flaps were extended. This creates a ton of drag. It's kind of like throwing out an anchor. So without engine power, the plane was slowing down incredibly fast. It had flown right into a silent trap. Okay, so after the crash, when the Dutch investigators recovered the flight data and cockpit voice recorders, the black boxes, the full, shocking story of those final minutes finally started to come into focus. And the first thing they found was just baffling. The cockpit voice recorder showed no panic. There was no discussion of some major emergency. They were conducting the approach in a totally calm, routine way. It was only in the last few seconds that confusion and alarm suddenly erupted. The flight data recorder, though, held the answer. What the investigation revealed was that it wasn't just one thing. It was this perfect, terrible storm of failures. You had a technical fault, the altimeter, and that was combined with human factors. The crew was distracted by their high workload and, a certain level of automation complacency, just assuming the system was doing its job normally. And all that led to them not noticing the plane's energy state until it was just too late. So when the official report came out, it laid out that fatal sequence crystal clear. It started with the sensor. The automation acted on that bad data, and the crew missed it until the plane was so low that recovering from the stall was physically impossible. But the story doesn't just end with the crash report. This accident actually became a landmark case study in aviation. It led to critical safety changes that are still in effect today, protecting flights all over the world. And this might be the single most important takeaway from the whole incident. The plane itself was perfectly fine. The automation was actually working exactly as it was designed to. The failure was in the interaction. The crew didn't realize why the automation had cut the power, and that led to a situation they just couldn't recover from. As a direct result of this, the industry changed. Pilots now have to train for this exact scenario in simulators. Procedures were updated to force pilots to aggressively monitor their speed on approach. And there's this huge new emphasis on something called mode awareness. Pilots have to know, at all times, what mode the automation is in and why it's in that mode. And really, it all boils down to this one powerful philosophy that just echoed through the industry after this accident. Automation is a tool. It's an amazing tool, but the human pilot must always be watching it, ready to step in, and ultimately be ready to fly the aircraft. The lessons from Turkish Airlines 1951 are more relevant today than ever. It really forces us to ask this critical question as our technology just gets smarter and smarter. How do we design our systems and our training to make sure the human pilot stays fully engaged, fully aware, and always, always in command? It's a powerful reminder that behind every single safe landing, there are thousands of lessons, many of them learned the hardest way possible.